Welcome to a lesson with Dr. Powell. We are going to go through a few practice problems here on limits. So I'll present the problem and then you can work on it. Pause the video. So pause the video, then you can work on it, and then keep the video going, and I'll work through an explanation of the solution right over here. Okay, so here's problem number one. We are taking a limit as x approaches -2 from the left side of f of x. F of x is described by this piecewise function, a different definition for the output of f when the x value inputs are less than -2 versus when they are greater than or equal to -2. Okay, go ahead and work on it. All right, here's the solution. So since we're heading toward -2 on the left side, and the expression that represents the function on the left side is a continuous function, we can just simply plug in -2 itself into this left part. Even though this is less than, we don't have an or equal sign, because guess what limits are? Limits are hole fillers. We're trying to figure out the hole filling that needs to be taken into account, so which y value would fill the hole on the left side of this function to make this function left continuous at the point x equals -2. All right, so that's why we're going to plug in -2 here. That's because we're coming on the left side. And these or equal to's don't even matter at all when we're taking limits, because limits are all about filling holes. All right, and we're going on the left side here. Okay, so we can plug in -2 on the left, and this one's fairly straightforward. That's just all it is. It's just the explanation of what we're doing. So -2 is plugged in here, minus 3, or this becomes +2 minus 3, so that'd be a -1. Absolute value of -1 is +1. So then we have -4 minus 2, so we'd end up getting -6. Okay, so that's the solution for number one, taking a limit on the left side. Okay, I'm going to add in a number one, part B. Part A was this. Part B is, what is the limit as x approaches -2 from or just -2 in general, of f of x, using this exact same description of f of x. All right, I'm going to try it out. Go for it. Okay, I'm going to work out the solution for that one. Okay, so, well, how is this done? Well, we just found right here, this is the limit as x approaches -2 from the left side. We got that. So for the work for this, we need to write out what we're comparing. We need that the limit on the left side, which is -6, needs to match the limit on the right side. And if those limits match, then this limit will exist. So let's see about that. What's the limit on the right side? Well, here we're going to be plugging -2 into the expression for x values on the right of -2. So we plug in -2 over here, and notice that we get 2 times -2, which is -4 minus 2, which is -6. Now note that both of these are the exact same. So that means this limit actually does exist, because we are coming in from left and right and getting to the same point, and it's going to be that y value that we're getting on both, that common y value that we get from both. It's -6. In particular, that means that this function is continuous in general. So because the y value that we need to make it left continuous is exactly what we already have right here on the other side, on the hole fill-in. It's already -6. So we know it's left continuous. It's right continuous because, well, we filled in the hole at the right point into this with the or equal. Therefore, it's continuous overall. Continuous on the left and right. It's continuous in entirety. Okay, so that was number one, part B. Just kind of added that in as we were going. All right, now let's look at problem number 2. Okay, so we're taking a limit as x approaches -2 of f of x, where f of x is a piecewise function. Okay, so this is not a limit on the left or right. This is just a limit overall. Does this limit exist? And if it does, what is it? Okay, go for it. All right, I'm going to present the solution now. All right, so to do this, we simply just plug in -2 into both parts, all right? So the definition on the left, definition on the right, plug in -2. So you plug in -2 here, and what we're going to get +4 on the left. So the limit on the left is +4. If you plug in -2 on the right, you're going to get 0. Notice that. Limit as x approaches -2 on the right of f of x, we get 0. Notice that these guys are not equal. That means that this limit is undefined. It does not exist. Okay, now we're going to go on to number 3. Okay, we're taking the limit as x approaches 0 from the left side of f of x, and f of x is equal to this. All right, ready? Go for it. Okay, now I'm going to present the solution here. So we have the limit. Okay, so how do we do this? I mean, this is like, you know, this absolute value thing. I mean, we can kind of draw a graph and kind of see what it goes, you know, plug in different points and kind of see what it's tending to as you're plugging in x values that go to 0 through negative numbers just to the left of 0. So, or we can look at f of x itself and think of it in a piecewise way. So, all right, what is absolute value of x, first of all? Well, I mean, when x is positive, it's just itself, right? And I can even do that. I mean, with 0, it's itself as well. And then when x is negative, you're going to be changing its sign. Now, how do you change the sign of something? You just put a little negative sign in front of it, and it'll change its sign. Because if it's negative, make it positive. If it's positive, make it negative. It's great. So negative x, that's the way to change signs right there. And then we have x is, so that's, we want to change the sign when x is less than 0. So automatically, absolute value of x is just this. All right, well, what are we doing with the absolute value of x? We're multiplying it by 3 and dividing it by x, like the output of absolute value of x, all right? So multiply it by 3, isn't that just that? And then you divide it by x. So divide the output by x. These are the outputs, so divide them by x. What does that look like? That looks like 3, -3, because the x's cancel there and there, when x is greater than or equal to 0, when x is less than 0. Oh, okay. So that means on the right-hand limit is 3, the left-hand limit be -3, and we're looking for the left-hand limit. Great. So this will be equal to -3. That would be the solution. Okay. So that's the solution for that one. Now we're going to go on to another problem here. Okay, number 4. So you ready? Go for it. Okay, here's the solution. You can check yourself. All right, or an explanation of the solution, which is what we're looking for, like why this would be true, or what. So what the solution is, and then why is it the solution is the idea. So getting a nice explanation. So here's my explanation for this one. So we're taking the limit of f of x as x approaches 2. Now, again, you know, we can think of this the same way as I did the last one. The absolute value of x is equal to x when x is greater than or equal to 0, negative x when x is less than 0, right? What are we doing with it? Okay, well, first of all, we're replacing the input, the absolute value, which is x marks the spot, right here and here. What are we replacing it with? And even right here and here. So all these x's, we're replacing them with what's on the inside of absolute value, right? So we kind of have an input slot for what opposite value is. It's there, 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 and there. So we can replace this with negative x plus 2. Negative x plus 2 is equal to, and we can just write this out, negative x plus 2, and then we put negative of negative x plus 2. That negative, well, I'll just write it out. I mean, you can distribute in your head, but I'll just write it out so you can see it in its entirety. Negative x plus 2 greater than or equal to 0, and negative x plus 2 less than 0. Okay, so great. And we can rearrange this if we want to. I mean, we can add x to this side, so we can rewrite this inequality as simply x, because we just added x to both sides. This one, we can, again, add x to both sides, and we end up getting 2 is less, so x is greater than 2, or x is less than or equal to 2. So this is on the left of 2, and this is on the right of 2. Great. And that's kind of what okay, so we can compare the different left and rights. That's awesome. Now what are we doing with this? Well, looks like we're taking the opposite value, the output of it, which is here and here. So these are the outputs. I mean, this is a condition of when it's happening. It's not the output. This is the output. So if we do something to the output, we do it to here and here, right? In different locations. Those are just the locations. Okay, so we can multiply, if we multiply the output of opposite value by 4, we're multiplying this guy right here by 4, and we're multiplying this guy right here by 4. All right, and then we're dividing the output of this whole thing by x minus 2. All right, so think x minus 2 and dividing that by x minus 2. All right, so we have a different expression for the left and the right. Okay, let's see what these are as we go along. Let's look at the left expression. It's 4 times negative x plus 2. Now, I'm just going to factor a negative out of that expression. So if I factor a negative out, then what are we left with? An x, and you can trace it back. If you put the negative back in, you should get this. So if I put the negative back in, I should get negative x, right? What do I have to have here when I put the negative back in? A negative 2, because notice when I put the negative back in with the negative, it'll be positive 2. So you can double check that you can work backwards to verify that this is equal to this, all right? That numerator. So negative 4 times quantity x minus 2 will be the same as this. You can check yourself and see. Okay, in particular, negative 4 times negative 2 is positive 8. 4 times positive 2 is positive 8. Let's get negative 4x, get great. All right, awesome. Now, why in the world did we do that on the left side? So this is the expression on the left. Because I noticed that the denominator looks like an x minus 2. It's nice to have the same thing in top and bottom. Why? Well, it will cancel now because they're factors of both. And if you have something that's a factor of something on the top and factor of something on the bottom, I mean, you can divide by the same thing on top and bottom and get rid of factors. You can't get rid of addends, like things that are added on that are the same. You can get rid of things that are multiplied that are the same like that. So you cancel out. Looks like on the left side, the expression just simply becomes negative 4. Likewise, let's see what happens on the right. So on the right side, we'd have, okay, so notice that this negative will distribute through. When it does, you'll actually get x minus 2 itself. So on the right, we just get 4 times x minus 2 divided by x minus 2. Cancellation, we get positive 4. Uh-oh. The expression is negative 4, a constant on the left, which means the limit must be negative 4 on the left side. I mean, you plug in anything into a constant, you'll get the same constant, right? So on the left side, you're going to get negative 4, but on the right, you get positive 4. Notice that these two things are not equal, and here we're looking at a two-sided limit. Therefore, this limit is undefined. Okay, that concludes this set of practice problems. Thanks for watching.